this is 15 degree, 75 degree. This can change. You can have an isosceles triangle also as a right angle triangle where this is 90 degree, 45, 45. So this side and this side are same. So this is a right angle triangle as well as isosceles triangle. Make sense? Anirudh, still a question? No? Okay.
Wait, I'm still kind of confused on how you found the angles for the triangles.
No. I'm just giving you an example. I could not find anything. I did not find anything. I was just giving you an example. You said that, does it mean that every right angle triangle will have similar triangle or matching triangle? I'm saying no. You can have different right angle triangles. You can have a right angle triangle. See, the only criteria for having a right angle triangle is one of the angle is 90 degree. Only one angle is 90 degree. Now the other two angles can be aligned in different ways. It could be 45, 45, it could be 10, 80, it could be 15, 75, it could be 189 also. Yeah? Make sense? Doesn't make sense. Anirudh, I will not let you go unless you say yes.
Wait, how did you get the angles? Like, I understand how you got for triangle ABC, I understood how you got the B angle, but how did you get A and C?
A and C?
Because of this thing.
No, not for you. Yeah. What do you mean by A and C? These two? These two? Yeah, Anirudh. Unmute yourself and tell me.
Oh, yeah, I'm talking about angle, yeah.
Yeah, A and C. See, I'm saying your triangle could be different. It could be different depending on how you have constructed your triangle. If your triangle is like this is still a right angle triangle. Here it is 30 degree, it is 60 degree maybe. I'm saying there could be different combinations of right angle triangle. I mean the angles in a right angle triangle, that's what I'm saying. Because some of all your angles will be 180 degree for a triangle. Since it's a right angle triangle, one angle is 90 degree. Other two will distribute among themselves. There could be different shapes, different combinations. Yeah?
Wait, but how do you find those angles? Like, how do you know the exact, how do you know?
I did not find anything.
Okay.
I did not find anything. What I'm saying is, see here also I'm just saying the name of the angle. I don't know whether it's 1 degree or 75 degree. I don't know that. And I'm not trying to prove that. That is not the objective. Yeah? Okay, so coming back to what I was trying to prove. And it is important for you all to know how Pythagorean theorem came into existence because 95% of the population till high school, I can give you on writing and it's getting recorded, to go to YouTube in a public domain. I can challenge 90%, 5% of the kids don't know how it is proved. Even 12th graders, forget about you guys. Okay?
One day I'll go to Harvard.
Okay? Yeah, Vishal.
College people.
Okay, let's not go there.
What
In,
about Harvard?
in another class, I learned another way to prove the Pythagorean theorem.
Right. So I'm saying, people just know what is Pythagorean theorem, but not everybody knows how to prove it. That's my point. Right? So here, based on whatever we have done, coming back to this one. So there was a right angle triangle. We had drawn a perpendicular from here to here, which made two more right angle triangles. And by seeing all that we have done, your feet down. What we have seen is this triangle is similar to the last triangle. This triangle is also similar to the last triangle. Same regions. Both have 190 degree matching and this one angle being common. Third angle doesn't have a choice, it has to match. So what it means is, I am writing this as a theorem. So triangle ABC, okay. Triangle ABC is similar to triangle ABD. So larger triangle is similar to triangle ABD. And then triangle ABC is similar to this small triangle also, which is BCD. Okay. Now what? This doesn't prove anything. There is no Pythagorean theorem yet.
Yeah.
So hold your horses before your horses start running in all directions. Okay. Now First one, let's take this combination ABC, this triangle and this triangle being similar. What does it mean? The sides will be in the same proportion. So, if you look at ABC, let's take side B, this one BC. So, BC divided by this small triangle. This is the common and matching angle, right? This is same. This side will apply to this angle and this angle is common anyways. So, this by this side BD will be equal to, let's take the second side, this one, hypotenuse of this one, which is AC divided by, what is the hypotenuse of this one? This is AB will be equal to, let's take the third side, AB divided by, this is AB, the last triangle is the side opposite to this angle. Now this is this angle. This angle and this angle are matching. So AB by AD. Now again you will be thinking what I am doing. I am not doing anything. I have this triangle and this triangle similar. So I am picking up the common matching angle and the side opposite to that. I am plotting it here. That's it. I pick the first big triangle, pick this angle first, angle A. Side opposite to that is BC. BC divided by, and this angle is common both, so side opposite to this will be BD here. Similarly, when I pick the angle, second angle in this one, let's say angle B, 90 degree. The side opposite to that is the hypotenuse, AC. Now the hypotenuse here is side opposite to this one, so AC divided by AB. And I pick the third side also. This is the equation that I am getting from the first equation. First combination of similar triangle. So let me do one thing. Let me pick these two. And then AC by AB equals AB by AD. Or I can do, this goes here, this goes here. So AB times AB equals AC times AD. Or AB squared equal to AC into AD. I got one equation here. By this triangle being similar to the last triangle. Okay? When they are similar, I will pick up the matching angle, the side opposite to that, I will just put the proportion here. And then I picked one combination which gives me AB in one place. So this gives me one part of the equation. So AB squared equals AC into AD. AC into AD. I got this one only so far. Let's keep it here and write this equation here. So AB squared equals AC into AD. Yes, somebody raising hand. Yes, Anirudh.
Okay, wait. So the line which we got crossing DB, do you know the line which is crossing line DB, like A something?
So okay. So let's give every angle a name. 90 degree is a 90 degree. Okay, this is C. If this is C, which angle is equal to this one? This is C here. Okay, because this one is anyways common. A is common, 90 degree is here, and this angle is equal to C. Now, when these two triangles are similar, then the sides opposite to the matching angle will be in the same proportion. That's what it says, right? Now you pick angle A first. This is angle A. Last triangle when you pick, what is the side opposite to that? BC. Now, in the small triangle, same angle, matching angle, it's a common angle anyways. So BC by BD equals, now pick the second angle. Let's pick the 90 degree angle. What is the 90 degree angle? The large, this angle B is the large, it is the 90 degree angle in the last triangle. Side opposite to that is what? AC. Divided by, pick the 90 degree angle in the small triangle. Side opposite to that is AB. And remember this, when you talk about the similar triangles, how do you pick the sides? Since you are saying that it's the base of the angle, right? Which they have matching angles. So you always pick the side opposite to those matching angles. Okay? And then this equals, if I am picking up the third angle, which is C, What is the equivalent of C in the small triangle? This one, because this is 90 degree, this is matching, this is common, so this is the only angle which is matching.
That was a lot of info.
Right? That was.
A lot of info.
Mm-hmm.
That was
So-
what the same was.
From there. So yes, Dikshita, you have a question. I know there's a reason to get confused, but that's fine. Let's see.
So how do you multiply AB times AB? Because they both are same, right?
No. So see, let me write it first. Let me write one more time. So I have written this one for two of the matching angles. Now let us see the third angle, which is C. Side opposite to that is AB. If I'm looking at the large triangle, and if I'm looking at the small triangle, this is the matching angle C. Side opposite to that is AB. So this is nothing but an equation. I can pick these two and say these two are same, and that becomes my equation. I can pick these two and say this is the same, so this is my equation. Or I can pick this and this same, and that becomes my equation. I chose these two because the reason is I found AB in both the places, and my objective is to get AB square, BC square, and AC square, right? So I found AB in this place in both this combination, so I picked these two to compare with. So AC by AB, if I pick this combination, says AC by AB equals AB by AB. Now I'm just doing simple algebra, getting everything in one side. Or keep it quiet. This is how it traverses, right? If I make it cross the equal to sign, whatever is the denominator becomes numerator, or vice versa. So this goes here, this goes here. That is how it became AB times AB equals AC times AB. Is that clear, Dikshita?
Yes, sir.
Okay. Now, from this I got this equation which says AB square equal to AC into AB. That is enough. That is what I know so far. Now let's look at the second combination. We have already seen that this baby triangle is also similar to the last triangle, meaning triangle ABC is also similar to the baby triangle, this one BCD, and BCD is in blue, so you want to color it blue. Okay, now the same thing, since we know that this is similar because we saw it, this angle is common and the other angle is 90 degree, triangle has to match. So if you look at this triangle and the last triangle, this is a common angle, see, this is 90 degree, this is 90 degree and this is 90 degree. Now what is missing is this A. This is, A is equal to this one. I will call this part as A. Okay, this angle. Now you see here, the sides will be in the same proportion. So let's pick the large triangle first. Let's take the side, let's take BC. So BC is opposite to A. So BC divided by, what is the equivalent angle for A? This one is equivalent to A. Side opposite to that will be BC. BC by BC, BC by BC will be equal to, let's take AC, the hypotenuse. AC divided by the hypotenuse of large triangle by the hypotenuse of the small triangle. This is the hypotenuse now because this is up to 90 degree. So this is AC by BC. And the third, if I look at, we have not taken AB. AB is the last triangle. So AB divided by, AB is the side opposite to C, and C is common in both the triangles. So side opposite to this will be BD. Now here, what is my motivation? See, which combination I want to pick. Do I want to pick this one, this combination, or this and this? I would want to pick this one because here I have got AB square. If I get this one, BC goes here, becomes BC square. Yeah. So I will pick BC by DC equals AC by BC. These two combinations. And that makes it this way. So it becomes BC square equal to AC into DC. Again, lot of math around this, but what happened? Try understanding before you react. Okay, that's important. So here again, it might look cryptic because I'm saying BCSE. These are all look. This all might sound like jargons, but summary is this. Summary, I said this is similar triangles. Two triangles having matching angles, equal angles, and when the angles are equal, the sides opposite to the matching angle are in same proportion. That's it. That's the theory. Now whether you call it AC, BC, DC, PC, MASI, whatever you call it, it's okay. Yeah. All right. We are just looking at the sides opposite to the matching angle and then finding it out. That's it. So second equation we got is BC square equals to AC plus AC into DC. So basically, if you look at a summarized form of this, you have two equations. One equation says AB squared equal to AC into AD, and second equation says BC squared equals to AC into DC. Now, what is your AB square? This is your A, this is your B, and this is your C, as per the Pythagorean theorem. So, AB square, I will write this as A square equal to AC into AD, and BC square is nothing but B square equal to AC into DC. Now, you just add these two, meaning A square plus B square equals AC into AD plus AC into DC. And what it means is AC is common in both the places, AD plus DC. AD plus DC. What is that? That is also AC. That becomes AC square or equals C square. What happened? A square plus B square equals C square.
What a big surprise.
Huh?
What a big surprise.
It's not a surprise. We are just holding our horses because
Wait,
horses.
So we don't keep my tax. What was that number?
Wait. Focus your talk. Doesn't take you anywhere. Stop it there. Don't just start a fresh discussion here. Now let's summarize before you guys start hating me for this complicated thing. There was a right angle triangle. We were trying to prove the Pythagorean theorem. What did we do? We had a right angle triangle. From here we have drawn a perpendicular on the opposite side. Out of here. By doing that, what we saw is there are two new right angle triangles made. And this right angle triangle is similar to the last triangle. Again, we saw why. This right angle triangle is also similar to the last triangle. Then also we saw why. If the triangles are similar, the sides will be in the same proportion. That's what we wrote as an equation. If they are, we just looked at the matching angle. So this angle is equal to this angle. This angle became equal to this angle. So when we look at this and last triangle combination, we wrote the equation. But then we looked at this triangle and the last triangle similarity, wrote the second equation, and then we added them together. That's it. Easy?
Exactly.
No, I know.
My,
It's,
my diary taught me some of this.
Okay.
When I was in third grade.
that is why you are making mistakes.
Actually,
You don't learn things which you are not supposed to learn at a very young age.
because in my dad, it was a time.
Stop it there. I'm not wanting to go into that discussion because that is not going to go good. That's not going to go good. When we are already running ahead of time. You are in 6th grade. I'm teaching things that is needed in 8th grade. Now, if you say you learn in 3rd grade, then you should not be making any mistake. And I see you making mistake every day. So eat only what you can digest. Because overdose of eating leads to food poisoning, and that hurts. Okay.
I never experienced.
Alright, so question here to everybody. Were you guys able to follow what I did? See again, none of you would be required to prove the Pythagorean theorem, okay? Trust me, you don't need to. What is important for us is to understand how this came into existence. And only thing I would want you to remember is, this is based on properties of similar triangle. If you have a right angle triangle, you draw perpendicular from here. This creates this triangle similar to large triangle, this triangle similar to large triangle. If you remember this property of similar triangle which says that the sides will be in the same proportion, you can do your math and prove it if it becomes a question of life and death. You would not be required to. But if it comes to a point that okay, your score will go for a toss, then you know how to start. I don't think I memorized this. I just knew that similar triangles have their sides in the same proportion. That's it. And I did the math. So get into the habit of doing more and more maths. Keep practicing sums. Don't be afraid of trying something even if you don't know. Keep doing it. And then you'll be able to get to a solution. Pythagorean theorem might look like a horror story. There might be different ways of solving it, like Vishal said. This can be explained in 5 different ways. No denying that. What I'm saying is, you learn all the things that you learn from people and then see which one is easiest for you to remember. I find this one easy for me to remember, so that's why I